Hello, everyone. You are welcome to today's lesson. And in today's lesson, we are going to bring the curtains down on the elective math sequences and series. Okay, and we'll be looking at solution to selected past questions and likely exams questions. Okay, for some of them directly picked, okay, from the past question. Some I picked the past question, altered it, okay, for me to assess you based on whatever that I want to bring out of you. So some will be direct, some will not be direct. So the indirect ones are the one that, okay, I am calling likely exams questions. And also I added mine as well. Some of the questions are not past questions. Okay, great. So now, quickly, let's go and have a look at what the solution that we can provide for this particular first question. All right. So as usual, when you read question, the first thing that you write is for solution. Okay, so we are going to have that one, okay, done. So we are going to write solution. That's the first thing that we write. Okay, remember I said as you read question, underline the salient parts. Okay, the limiting sum of an exponential, I'm reading the question, sequence is 9. If u sub 2 is equal to 2, find the value of values of I, A, and you know A is the first term, and I are the common ratio. And you know u sub 2 is the second term. However, please, we know we are dealing with exponential sequence. What do you understand by limiting sum? I think this is the first time I'm introducing you to this. Okay, I mean this word, limiting sum, or these words. What do you understand by that, limiting sum? Any ideas? Limiting sum. You might think it's something new that you've not been taught. I mean, in terms of by the nature of this question, immediately you see limiting sum. What is limiting sum? Mr. Ackman didn't teach us limiting sum. And please, I taught you. Only that, okay, I didn't use these words. Okay, take note. Limiting sum is the same as sum to infinity. So anywhere you don't see, okay, sum to infinity, you see limiting sum. So meaning the two can be used interchangeably. Am I clear?
Yes, please.
So that's all. So if that's the case, this is the only note in the question. Okay, I think so far. And when we were treating, okay, the sum to infinity, I intentionally, usually I write sum to infinity or limiting sum. But I intentionally didn't do that. Okay, so at this point, because knowing that, I remember I would wanted to give this one to you as an assignment and see whether you would tell me that I didn't teach you, because I wanted you to equally research and get your own, okay, facts. Okay, but now we are doing it together, so let's go. Questions are numbered because we want you to number your solutions. So now, given, we are going to extract what we've been provided with. So given limiting sum of an exponential sequence, so it means sum to infinity is equal to 9. Do you agree?
Yes, please.
Okay. And again, and u sub 2 is equal to 2. So these are the two basic information provided in the question. So this long statement that we have here, that's what we have extracted mathematically over there. Okay, we need to find the values of A and R. So that means two unknowns, and we cannot find two unknowns with only one equation. We have to generate at least two equations, and that's exactly what I am going to do. Okay, so at this point, we are going to write, if you take the first relation here, this implies that we are going to use that one to generate our first equation. So please, okay, S sub infinity, which is the sum to infinity. What is the formula for that? What's the formula for sum to infinity? A over 1 minus R, am I right? Okay, and that is equal to 9. My professors, can you hear me? Are you there? You are not responding. Or my network is not stable. Can you hear me?
Yes,
We
sir.
cannot hear.
You cannot hear me.
We can.
You can. All right. Okay. So perfect. So please. Okay. Some of the questions are not rhetorical. You know, I want to know. Okay, that you are with me, or you are alive and kicking. So that will be. This is what we are going to do. We'll label this equation. Remember, I said before you label an equation, make sure it is devoid of fractions or brackets if possible. So I won't label my equation at this point. I will write this one as A is equal to 9 into 1 minus r. And that will be my equation 1. Okay, this contains brackets. Okay, can I label it based on what I just said?
No, please.
Okay, all right. Okay, so take note. You know, for every rule, there will be exceptions. So what I'm going to do is, for now, I am going to label it at the bracket point at this point. Okay, and I will tell you why it is so. Okay, so this is what we are going to get. I'm going to get this to be, okay, 1, equation 1. And per experience, you also know that it will be better this one, you do it. You don't go by the usual way. Remove brackets, remove fraction before you, okay, label your equation. So, and we are going for our second. So the second term of an exponential sequence, you know you are dealing with exponential sequence. So the second term of an exponential sequence is given by, is it AR? Do you agree?
Yes, please.
Okay, so it means AR is equal to 2. Are you with me?
Yes, please.
Okay, so this becomes equation 2. Okay. Please, do you know why I did this? I didn't expand. You know, if you expand, you come and substitute. When you substitute, you factorize. So I have done the factorization here, sort of. So it means, okay, part of the work done here. That's the more reason why, because I am going to use substitution. I'll substitute equation 1 into equation 2. Okay, Prof. Herbert.
Sir, please, I want to say that where from the AR is equal to 2.
Okay, all right. Remember, we are dealing with what? What do you call a GP, an exponential sequence?
Yes,
All right.
yes,
Were
sir.
you with us when we did the Commons GP?
Say yes.
It's just a weekend. We didn't need the before. All right. Okay, so this is what you need to get. We said U sub n is equal to what? A r to the power n minus 1. Is that not it?
Yes, sir.
So if n is 2, so U sub 2 will be equal to A.
Okay.
Remember I said at this point we are mature, so we don't need to quote this. Once we know n,
Oh,
we'll be able to generate that. So your
okay,
first term
sir.
will always be A. Your second will be AR. Your third will be AR squared. Okay, and what have you? Okay.
Okay.
And all right. So okay, so if we are fine, then I think we are good to go. Okay, so here we want to use the substitution method. So A, in equation 1, A is made a subject. So I'll come and substitute that one into equation 2. So I'll write equation 1. And please don't write puts. I saw this in some of your presentation. Don't write puts. Just come and write the name of your equation. So it will be regarded as equation 1. And write into, okay, the equation that you want to put that into. Don't write puts. If you want to write puts, then make it continue to be put in. Okay, if you want to write substitute, write substituting. So you are doing that. You don't command the person who is marking. If you write put, substitute. Indirectly, that's what you are trying to tell me. I should put. Okay, we shouldn't be. All right. So if you are putting, just write putting. All right. So, but I've told you it's not necessary. Don't let that waste your ink and time. Okay. So now it means wherever I see A in equation 2, it is 9 into 1 minus R. So I'm going to get 9 into 1 minus R, then times R. Do you agree?
Yes, please.
And that is equal to what? 2. Okay, so what do I get at this point? I'm going to expand, okay, then make my R the subject. Is that not it?
Yes. Yes.
Okay, so we are solving for R. Now the only variable unknown is R. So we are making R the subject. So you are going to get 9, 9R. Am I right?
Yes, please.
Okay, so you get 9R minus
R.
R
9R.
squared.
9
Okay, so
R.
9R squared. I don't know why. Okay, so you let me continue. It's equal to this. Am I right? Let me write it well. Okay, 9R squared. Let me write it well. My professors, are you following?
Yes, please.
Okay, so what type of equation are we confronted with here?
Please, a quadratic equation.
Quadratic equation, only that is in terms of R. Okay, so what do we do? In order to solve quadratic equation, we first of all check whether it's solvable by factorization, because that's the convenient method or approach. Okay, so here you should always make sure that your leading coefficient is positive. So it means I'm rather going to move these two terms to this side, because my R squared term, which is my leading coefficient, the coefficient of a term with the highest power of your variable. So we are going to get, I will move 9R squared minus 9R plus 2 is equal to 0. Do you agree?
Yes, please.
Okay, Prof. Herbert, is it the old hand that is up?
Sir, no.
Okay, all right.
Sir, please. Shouldn't it be -2?
Okay, where from the -2? Are you talking about this?
Yes, sir.
Okay, you can see these two terms here, but remember I said we are rather moving to this side.
Oh, okay.
Okay, though I wrote them first, but you are moving to this side. So you get 0 is equal to this. We the same as this is equal to 0.
Okay, sir, I understand.
Perfect. All right. So now what do we do? Okay, we know unfortunately our leading coefficient is not 1. This cannot be reduced. So we have to multiply the 9 and the 2, which will give us 18. So we are looking for factor pair of 18, which when you add, you will get -9. When you multiply, you get 18. So I'm waiting for you. Any factor pair?
-6 -3.
-6 -3. Please, do you all agree?
Yes,
Yes,
please.
Okay, so we will use these two factor pair to split this. So that will give you 9R squared minus what? 6R minus 3R plus 2. Okay, is equal to 0. So we are going to, please, I've told you, don't use bracket to group. Group mentally the first two and factorize. The last two mentally and factorize. Don't use brackets. It can put you in trouble. So that will give me 3 can come out here, am I right? And R as well. So that will give me 3R minus 2. Am I right?
yes,
Okay, your first term here is negative. So you factor out 3, -3. Oh, sorry. It will be negative, that will be out, not -3. So you factor out negative because your first term is negative. So negative out. Okay, we are going to get what in brackets. There is 1 here, simply understood to be there. So 3R minus 2 is equal to 0. All correct?
yes, please.
Okay, so at this
Yes,
point, okay, what do? We are going to completely factorize. Let me complete that here. Okay, so it doesn't really matter. So I will get 3R minus 1 into, okay, 3R minus 2. Okay, it's equal to 0. Am I right?
Yes, please.
yes,
Okay, so you set each of the factors to 0 and you solve for your R. That step very critical. So 3R minus 1 is equal to 0. Or remember this connector, very important. You can't use comma, you can't use and, or you can't ignore altogether. Okay, it should be there. Then 3R minus 2 is equal to 0. Come and solve for your R in each of them. So 1, 3R is equal to 1. Again, write it again before you divide. Most of you are doing well when it comes to this. So R will be equal to 1 over 3 here. Then you come and do same here. 3R is equal to, okay, 2. Write it again before you divide over 3. over 3. So you get R to be equal to 2 on what? On 3 here. So here, okay, we know the value of R. Once we know the value of R, we can predict that of what? The A, and later go and draw our conclusion. Okay. Otherwise, someone can write II. All right, therefore, R is equal to 1 over 3 or 2 on 3. Okay, then go and solve for that of the A. But let's finish everything, then we draw our conclusion, okay, using the question numbers. So if your R is equal to 1 over 3, okay, comma, what will your A be? Come and substitute that into, okay, equation 1. So A will be equal to, okay, 9 into 1 minus 1 over 3. Do you agree?
Yes.
Okay, so on that note, we are going to get, this implies that your A will be equal to 9. Help me deal with that.
2 and 3.
Okay, so everything here will be, so let 9 into 2 on 3. That's what you want me to write.
Yes, please.
Okay, so you know that this can go here 3. Is that not it?
Yes, please.
So which will give us, in effect, A is equal to what? 3 times 2, which is 6. All correct.
Yes, please.
Okay, then you go and investigate the value of A for the second R as well. So if R is equal to, this time around, 2 on 3, okay, we are going to get A will be equal to 9 into 1 minus 2 on 3. Okay, which will give us, this implies that A is equal to 9 into 1 on 3. Am I right?
Yes, please.
And this will go here 3 times 1. So we are going to get that to be equal to 3. Is that clear?
Yes, please.
Okay. So because of lack of space, this is what I'm going to do. Okay, I am going to write here my conclusion for, so A. Okay, just because of lack of space. Okay, I'll write A. I want to be smart. Therefore, R is equal to this or that. Is that okay?
Yes, please.
Okay, then now my I it's not A, it's I. So I'm giving my own numbers. You avoid that. So I. Okay, what are we looking for? So in that case, I'll write therefore A is equal to what? Is equal to, the first value gave us was 6. Okay, or 3. We are done. Okay, or I can put my I here because this starts my I. Okay, then clear this. I won't number that again. So we are good to go. My point well made, my professors.
Yes, please.
Okay.
Yes.
Ask questions, so as Herbert has been doing. I like that. All right, so I'm sure anytime he encounters this situation, okay, he will know how best to deal with it. So let's move on to the next question if you don't have any questions. Okay, all right. Again, I think I should leave this one for you, or we should do it together. The limiting sum of an exponential is similar to what we just did, with a positive common ratio is 25. And the sum of the first 2 terms is 16. The sum of the first 2 terms, so it means U sub 1 and U sub 2, okay, will be 16. Okay, I will help you generate the equations. Then after that, I will ask you to continue. Would that be fine with you, my professors? I think that is fair.
Yes, please.
Okay, any
Yes,
no?
please.
Okay, well done. Okay, so now, as usual, solution. Okay, we are going to extract. So question 2, giving, okay, limiting sum of an exponential sequence GP with a positive common ratio, underline this. Very important. Okay, it's 25. So it means my limiting sum, we now know that sum to infinity, okay, is equal to 25. Do you agree? Okay, and the second information that you have there, we said the sum of the first two terms. So the first two terms will be U sub 1 and U sub 2. Am I right?
Yes, please.
So it goes to imply that the sum will be U sub 1 plus U sub 2. And we are told that is 16. All correct.
Yes,
So
please.
that whole statement in English that we have there, that's what we have extracted mathematically. So at this point, we use the first statement to generate, okay, the first equation and the second statement to generate the second equation. Prof. Karen.
Mr. Hackman, can I raise a concern?
Oh, raise. I was even expecting a concern, so I would be surprised if you didn't.
It's not about the work we do.
Oh, really? Now, my more fans for me, 3 more already, though.
Yes, please.
Okay, go ahead.
Please, someone wants to join the class, but then it's like he's in the waiting room or so.
No,
I don't know.
my class, there
And
cannot be
he's
any
stuck
waiting
there.
room. My class is automatic, so there cannot be any waiting room. So I don't know who the
Because
person is.
he just sent me a message and
Who is that?
it's Safo unable to connect.
Okay, unable to connect. Ask him to, okay,
This
or
is
her.
Safo. Is it?
Okay, so ask him to restart. Okay, and rejoin and let's see.
Pardon?
Ask him to, or him or her, okay, to
Okay.
restart and try
It's
joining
like,
again. Okay, if he or she is not successful,
okay.
please ask her
Maybe
to
I've been trying for a
call
while.
me. Okay, so we can move on if it's not related to that. Okay, so
Okay.
U sub 1 plus U sub 2 is equal to, okay, 16. Somebody can write S sub 2. You know it's the same. Can you see that? I thought that was Karen, that was what Karen wanted to ask, whether this you can write S sub 2. Because that's the sum of the first two terms, the same as S sub 2. You get it?
Yes, please.
Okay. And very soon you appreciate why this is so. After that, I'll ask you to go and use S sub 2. In that case, you use the formula for the S, okay, for an exponential sequence together with this and see if you end up getting the same results. So let's go by this route and see. So now, if you take the first one, this implies that sum to infinity we all know is given by the formula A over 1 minus R. And we are told that is equal to 25. From where we are coming from, remember we said we will clear the fraction. So we are going to get A will be equal to 25 into what? 1 minus R. And again, per experience, we said we are not going to expand. So we'll leave this one as equation 1. All correct.
Yes, please.
Okay,
Yes,
very
sir.
good. Okay, so now we are going to use this one to generate our second equation. U sub 1, we all know is A. Is that not it?
Yes, please.
Okay, so it will be A plus U sub 2. Okay, Prof. Herbert, what will be U sub 2? Prof. Herbert, are you there? What's U sub 2? Okay, U sub 2, all of us, what is U sub 2? AR. Okay, so AR. And we are told that is equal to 16. Is that clear?
Yeah, please. 56.
Oh, forgive me. This one wasn't intentional. Okay, so 16. Okay, so this is what we have. Okay, so let's see if we can label our equation words here. Okay, otherwise, okay, I would advise we do this. Okay, just as the first equation came in its factorized form. Okay, the second equation, this side can be factorized. So factorize and see what will happen. But that is not really necessary though. You can choose not to and come and substitute this one here. later you go and factorize. But if you factorize and you substitute, you get the factorized form right away. Prof. Herbert, where were you? I called you, I mentioned your name 1,000 times. You didn't respond. Prof. Herbert, are you there? Okay, so let's go. I guess maybe it's network issue. Please,
Sir,
I can hear you now.
sir, I want to ask a question.
Okay, go ahead.
Sir, please, you said the sum of the first two terms. So, sir, so is it that it be U2 is called 16 because they say the sum of the first two terms?
Okay, what is U2?
AR.
What is U2? Is U2, whenever you see you are talking about particular terms, is that not it? U-subs.
Yes, yes, sir.
So if you write U2, then it should have been the second term is 16, not the sum.
Okay.
Okay, when we talk of sum, then it means you'll be summing some terms. But here you are told that the sum of what? The first two terms. So it means the sum of the first term, which is represented by U sub 1, and the second term, which is represented by U sub 2.
Okay.
Or
Okay,
I
sir,
said
understand.
this is also the same as S sub 2 is equal to 16. You could have extracted this as such.
Okay.
All right. Okay. All right. So if you are fine, then this is, I will not label it per experience. I know I have to factorize this side too. So I will get A out, then I will get 1 plus R, and that will be equal to 16. So you can see that once I factored out A, if I'm substituting for A, let me finish. Okay, I will call you. I'll call you. Okay. Because I'm saying something vital here. That's why. Because I want to learn first. Because, okay, I have factored out A. When I'm substituting for A, how many times will I substitute for A here in this equation? How many times?
One.
One.
Once.
If you substitute for A here, how many times will you substitute?
Twice.
Twice. And look at the length of A. So you write more. You get it? So per experience, it will be convenient for you to factorize both sides before you go and substitute. So at this point, I label this as my equation, equation 2. So now what do we get? We are going to generate, okay, this equation 1 into, okay, equation 2, okay, comma. And this will always be too short to take a line. So bring the comma and continue. Do your substitution here. So that will give me my A, which is 25, okay, into 1 minus R, okay, into 1 plus R is equal to 16. Do you agree?
Yes, please.
Okay, very good. Okay, so at this point, I am going to maintain my terms in R on one side. So it means I'm going to divide through by, okay, 25. So I'll write it again, then divide by 25. So that I will have only R terms here and non-R terms, okay, on this side. Then later come and expand this. Or if you like, you can expand everything together. But you still get a quadratic in R, which no term in what? In R. You get R squared term and a constant term. Is my point well made? Okay, otherwise, no problem. We can still expand the side. Okay, anytime you have expanded and simplified, if possible. So if I'm expanding this, I can easily multiply this. Can you see? We know the exact expansion of these two terms. These two factors. Can you see? This and this. Difference of two squares when you expand. Is that clear?
Yes, sir.
So can I say what I have here will give me 25 into 1, okay, minus R squared. Do you agree?
Yes, please.
Yes.
Please, who doesn't? Who wants me to come again? I've asked the question. Okay, you are all doing well. Okay, fine. Okay, so at this point, this is equal to 16. Okay, like I said, divide through by, why am I ignoring the one? Divide through by what we have here. Or better still, you can expand and later. So let's expand. Let's complete the expansion. So this gives us 25, okay, minus what? 25r squared is equal to 16. Do you agree?
Yes, sir.
Though I said I would have divided through here by 25, then later move this one to the side. Okay, in that case, I will even move the r to the side because it will be negative. So let's go. So at this point, I am making r the subject, only one term in r. It's a quadratic in r, all right. But this is a special quadratic. Remember, I told you anytime you have a quadratic and, okay, you have the square term and a constant term, there is no linear term. You can make what? Your variable the subject. Do you remember? Instead of factorizing. So at this point, I am going to do this. I'm moving this one is negative. I want to avoid working with negative. So I'll move this one to this side and move this one to this side. So I'm going to get 25 minus 16. What will that give you?
-9.
Okay, so no, it will not give you -9. 25 minus 16.
+9.
Okay, so +9 is equal to our random, and then move this one to this side. So that will give me 25r squared. My professors, are you following? Hey, you didn't tell me that I said I would generate the two equations for you and stop there. So I've done more than I promised. Okay, so let's continue. We are preparing for the test anyway. Okay, so I'm looking for r. I write it again before you divide. Only that this time I'm going to write the r term here first. Okay, but that doesn't mean I'm moving. Okay, so I'll get 25r squared, okay, is equal to 9 over 25 over 25. So I'll get r squared is equal to 9 over 25. So now I'm looking for r. I take the square roots of r squared. Okay, and that will give me square root of 9 on 25. Am I right?
Yes, please. Yes, please.
Hey, Mwabameka.
No, please.
Okay, why no?
It might be a minus square root.
Okay, Ella, was that you? Prof. Ella?
No, please. I was
Okay.
about to answer, but she did.
Okay, so it means what you wanted to say is what she has said.
Yes, please.
Okay, very good. Those who said yes, I'm right. If it was just a mere guess, okay, your guess was right, perfectly right this time around. Okay, if you said no, please see, I said before you take the square roots, okay, check whether you have sufficient information in the question to tell you that what you are looking for is really positive, it's really negative. Otherwise, you introduce. Do you have any information about R being really positive or it's really negative?
Strictly positive.
Really positive. Do you get it? So it means when you are taking the square root, if you introduce plus or minus, okay, by the nature of this, okay, information here, it means you are supposed to discard the minus answer and only stick to the positive answer for the R. Is that clear?
Yes,
So before that's why I said this question, I should have given it to you as an assignment or even in the as a test. Okay, for me to know that indeed you are paying heed to whatever that I tell you. So at this point, I'm going to get R to be equal to, and it's not for a fluke. I know that I'm not supposed to introduce this okay, I mean, subjecting this one through what we underline. So that will give us 3 on 5. Is that clear?
Yes, please.
Okay, so at this point, we've done, okay, the R, but we don't know the first term. Okay, I'm only going to guide you from here. I won't continue. I've done more than I promised. Okay, so once you know R, don't we know A? So we use this R to predict what our A. And because this R is only one value, you have to label it as equation 3 and come and write equation 3 into equation 1. Then you move on. The other one, we didn't do that because we realized that R, we had 2 values. Okay, so we straight away use if R is equal to this, then came to that. If R, but here R is only 1 value. So label it and go and substitute that equation label into this equation label. Is that clear? And that will give you your A. And once you know A, okay, which is the solution for the question A here. Oh, you were not asked, this is the 5th term. I saw the first term. Oh. 5th term, so it means, okay, we need to equally find the A before we can find the 5th term. Is that not it? Because what is the 5th term? Okay, Prof. Herbert, what is the 5th term? Use of 5 in terms of a GP is what? I want to be convinced whether what I said, you are now flowing with it. Okay, all the whole
Sir, use
so that will give you.
Sir, that will give me use of 5 in terms of a GP.
In terms of a GP.
Will be, yes, will be A bracket open.
No. Hey, you are missing your S and the U, so.
Say AS.
AS. As in us.
Say no.
But Velvet, okay, what is use of 2?
Say use of 2 is called AR.
Ah, so what is use of 5?
Say use of 5 will equal to AR the root of 4.
AR root of
4. AR raised to the power 4. Say raised to the power 4.
I'll give you permission to go and eat, okay? Okay, so you have it right. Okay, so this is it. Okay, it has nothing. This is the sum. Please take note of the sum S sub n formula and the U sub n formula. Okay, so if you are looking for U sub 5, you need the value of A and the value for R. We know that of R, so automatically we need to go and find A, so you will know. And your S sub, the sum of the first 4 terms, you also need, S sub n, okay, will be equal to, what's the formula for S sub n? What is our common ratio? It's less than 1, so you put A into 1 minus R to the power n all over 1 minus R. Do you agree? We know our A, we know our R, and your sum of the first 4 terms, so your n will be equal to 4. Yeah, you substitute and you know how to move from here. Afa?
Yes, sir.
Okay, so this will
Yes.
be it, okay, for this particular, question. At this point, I am going to give you your water break. I will give you maximum 3 minutes, then we come back. Okay, Prof. Christine.
Mr. Hackman, please, the substitution, when you did it, why didn't you use the factorization method?
To what? So
in
how would you have
substituting?
dealt with it using the factorization? Meaning you bring everything here. Is that not it?
Yes, please.
Okay, I said you can use it, only that I've told you that anytime you have a quadratic equation and you realize that there is only your square term, which is the variable square term, and a constant term, there is no linear term, use change of subjects. That will work for this special situation. But immediately you get any linear term, that's where we have to go our usual route. Multiply the coefficients of your leading coefficients and the constants. Look for the factor pair and split. So that one you use factorization by grouping.
Yes.
Okay. This is a special situation. However, if you want to use that method, it's allowed. Assuming you want to go for that method, that would have given us, remember, that would have given us 25 r squared minus 9. Do you agree? Is equal
Yes,
to
please.
0. So this one we know difference of 2 squares because this one is the same as 5r squared, okay, minus 3 squared. Do you agree?
Yes, please.
Which will give you 5r plus 3 in one bracket, 5r minus 3 in
Right.
another bracket is equal to 0. So you are now going to equate this one to 0 and solve. By then we are done. That's why
Yes, please.
special always will need a special way of dealing with it. All correct.
Yes. Yes,
Okay.
please. Thank you.
Okay. All right, you are welcome. So now I guess we can go for our water break. Okay. Okay, so you are welcome back from the water break. Let's look at our third question. The second one, we didn't solve it, okay, through and through, but I guided you. So I know you should be able to continue from where I left you. All right, so let's look at this interesting question too. Okay, this question, at the normal circumstance, we should all be able to do it because in the core maths, we encountered a situation like this. Okay, we dealt with questions of this nature, only that, okay, our terms given, okay, were, I should say, non-fractional or rational terms. Okay, but whether they are rational, irrational, what have you, we know how to deal with it. Okay, we are going to use the same concept. 3 consecutive terms of a linear sequence. Okay, so these are 3 consecutive terms. That's all that you know. Okay, so whether these are consecutive terms, 3 consecutive terms after the first term, or from the beginning, meaning from the first, this is the first term, the second term, the third term. Okay, this could be the second term, third term, fourth term. Okay, third term, fourth term, fifth term, they are consecutive terms. You were not told that these are the first 3 terms, which will always be, which will also be consecutive though. So take notes. So when you are writing it in terms of sequence, you have to be very, very careful. Unless you are assuming that there's the first term, the second term, and the third term. So here, this is all that we are going to do. So solution, like we did in the other one. Okay, so I'm dealing with a linear sequence. This condition, very critical. I need to find the value of n. Okay, so for, you know, you are dealing with an AP. So for an AP, you know, you are supposed to get a common difference. Am I right? So
Yes.
if 1 minus 1 over m should be equal to 6 over m plus 2. Okay, minus 1. Do you agree?
Yes, sir.
Okay, as simple as that.
Yes,
So,
please.
you know, you have only one unknown. And I've told you, if you have one unknown, you need only one equation, okay, to get what? Your unknown found. Okay, if you have 2 unknowns, you need at least 2 equations. So at this point, okay, you know how to deal with this equation. So what do? We are going to multiply through by the LCM. Or someone can write this as a single fraction, this also as a single fraction and cross multiply, which is allowed. I know you will multiply through by the LCM, which will be m into m plus 1. But I am going to, okay, do this. Write this as a single fraction, this also as a single fraction, then cross multiply. Or better still, you can collect like terms, meaning the terms in m and non-terms in m or non-m terms. Okay, you move them to the side. You can play with your algebra. That's all that I'm trying to say. So I am going to write this as a single fraction. So by that, this is what I'm going to get. This implies that now it's an equation. If I take this, my LCM will be m. Okay, this, okay, 1 is over 1. 1 will go into m times m. Sorry, times 1. So that will give you m. Then minus 1. Do you agree? And that should be equal to, with this one, the LCM will be m plus 2. Okay, m plus 2 will go into this 1 times 6. I'll get 6. Then minus, this is over 1. And it will be 1 will go into m plus 2 times. okay, times 1 here. So it is negative. So I'm going to get 2 terms. I put both in brackets. Okay, other than that, I'm doomed. So at this point, m minus 1, okay, over m will be equal to 6 minus m minus 2 all over what? Over m. So I want to simplify before I cross multiply. So I'll get m minus 1 over m is equal to 6 minus 2 will give me 4 minus m, sorry, over m plus 2, forgive me. My LCM here is m plus 2, not m. So at this point, you cross multiply and you are good to go. You solve for your m. Is my point well made?
Yes, sir.
Yes.
Can I hold on here and you will continue later? Did I hear no?
Yes, please.
Okay, I guess this girl, you've seen my head, right? You know I have a big head, so you want me to carry every load. I won't mind you. All right. Okay, so we are going to continue. Okay, once one student says that I have no option. So here we are going to cross multiply. But so far, where we've gotten to, do you appreciate the one who said we should continue?
No, please.
Okay, so where lies your issue? So you don't even understand the beginning and you want us to continue.
I don't have issues.
You don't have issues.
No, please.
So meaning we shouldn't continue.
We should continue.
Okay. No issues, but we should still continue. Maybe along the line you have an issue. Right.
Yes,
Okay, so
please.
let's do it. Okay, so here you cross multiply. And as you are cross multiplying, please take note. In JHS, usually you show your lines for cross multiplication, but in SHS, please don't. Okay, it will be regarded as this one is cancelled. So it will be your binomial here, m minus 1, multiplying your other one, which is m plus 2. Okay, it's equal to your m into 4 minus m. Is that what you write?
Yes, please.
Hey, did I hear yes?
No, please.
There shouldn't be even a single
No,
yes.
please.
If you said yes, you are doomed. You can see that here. Okay, why no?
The first term is not in the bracket.
The first term, this is the first term. So I should put this in bracket.
M minus 1.
Okay, so the first factor, this is supposed to be a factor. So this is supposed to be in bracket. Because what you are multiplying, each expression is more than a term. Please make sure you put each one in bracket if you cherish maths. And from here going, it will be m0 a0. So we expand this, which will give us m squared. Okay, this time this will give us plus 2m. Okay, this time this will give us minus m. This time this will give us minus 2. Is equal to 4m, okay, minus m squared. Am I right?
Yes, please.
Yes, sir.
Okay. Okay, so at this point too, should I continue? Should I still continue? Okay, you let me simplify the quadratic equation. At that point, whether you put a gun on me to continue, I won't continue or not continue because I know that you are more than able to deal with it. So a quadratic you can see in m. So I want to see, I have to move this one to this side. So that would be m squared plus m squared. That will give us, okay, 2m. Am I right? Squared. And this will be 2m minus m. That will give me m. But this m here will come here. So I'll get m minus what? 4m. And that will give me minus 3m. I hope you are following. Okay, so minus
Yes.
2 is equal to 0. Do you agree?
Yes, sir.
Yes.
Okay, so can we get factor pair of you multiply these 2 and this negative 2? So that will give us negative 4. So can we get factor pair of negative 4? Which when you multiply, you get negative 4. When you add, you get negative 3. Negative 4 and positive 1.
Yes, please.
Okay, so I guess from here you can continue. Okay. My professor who asked us to continue, should I still continue?
This is fine.
It's fine. Okay, great. All right. So at this point, you continue, then you conclude. Okay, take notes. Okay, take notes of. Okay, let me see. Okay, let me hold on. You should all do it. I'll call you to give me your answers and see what we are supposed to do with our answers. So I'm pausing. All right. So now that's okay. You've been given ample time to deal with it. Okay, Prof. Ekuyadam, so what did you get as your M values?
Please, 2 and negative half.
2 and negative half.
Yes, please.
Okay, so 2 and negative half. All right, so here, I just want you to check. I wanted to check whether the values that you will get there, any of them will be these two values. So if you had one of the values to be 0, then it means you cannot conclude with the 0 because you are told that M is not 0. If you had one of them to be negative 2, it means you can't conclude with the negative 2 because you are told that M is not equal to negative 2. You get it? So when you are concluding and you have conditions attached, please check, especially if your denominator is what contains your letter or your variable. Check and see whether it will make your fraction there define the values that you found. Is my point well made?
Yes, sir.
Okay, so that's all the difference about the other one that we had. Maybe this the variables were in the numerator. So that one you didn't mind. But here you have the variable in the denominator, so you have to mind the values that you go for. Okay, all right. Any questions? Otherwise, we move on to the next one. Okay, so the next one, this is it. Okay, so solution. Okay, we've been given series, and we know that out of every series, we can generate what? A sequence. So let's first of all determine, we are asked to find the sum of the series. Are we finding the sum to infinity?
No.
Okay, you know this sequence is a finite sequence. So if you are finding the sum should also be finite, not infinite. Take notes. Okay, so here, okay, what will be your approach? You solved a question like this before. So please make me proud. What will be the approach? In the sequence, we know the last term, am I right?
Yes, please.
Okay, so let's determine the nature of sequence, and that will help us quote the formula for the sum. Okay, because indirectly we are looking at the sum. So we need to generate the formula for the S sub n. And once we know our n, okay, and also the letters that are involved in the S sub n, we should be able to find the sum, okay, of this particular series that we have there. So as usual, let's see what type of series are we dealing with here? Is it AP or a GP?
AP.
AP. You all agree that it's an AP?
Yes.
Yes, please.
Okay,
Yes.
so you know you are finding sum, so you use the formula, the sum of these terms. So this is an AP. So this is an AP. And if you like, you can continue. For an AP, if you have, okay, space, you can continue. Okay, your S sub n, you know is equal to what? It's equal to, let's quote the formula. N over 2, I'm coming, okay?
Into
Then
bracket.
into bracket, will you write 2a? You know the last
Okay.
term, can't you see that?
A
Plus
L. So you
L.
have to quote the A plus L1. As simple as that. That's all that you need to know, because in this sequence that we are finding a sum, we know the last term. Okay, so you used, but how do we get our L? But we know that L is equal to what? A plus n minus 1g. Do you agree? Oops, forgive me.
Yes, please.
You agree? Okay, so I'm just walking you through. Okay, Prof. Amma, You can now ask your question. Oops.
Stack one.
Mhm.
Please, I remember you said even though the question given is in series, we can still extract it.
Yes, you can extract it in terms of sequence. It's allowed.
Okay.
You can extract it.
Without
no-
changing the positive sign.
Without changing the positive sign. As in, yeah, if you want to extract it, you can extract it in the series form, or you can extract the sequence out of the series. If you are
Okay.
comfortable working with the sequence.
Okay.
All right. Okay. So now, what do we do? Okay, we need to find our A and what D. We know A and D. Is that not it? We know A and D. Am I right?
Yes, sir.
So it means we can, and we equally know L, so we can find N. And once you know N, you are in a comfortable lead. So I can say that, but, so in this case, at that point, maybe you will know. So I'll write, this implies that my L is 27 on 2. Okay, it's equal to my A, 3 on 2. Okay, then plus N minus 1 into D. By then you have decided, you've done all that you were supposed to, because you did that before you wrote this is an AP, remember? So you will know your D. So give me the D.
3/2.
Come again.
3/2.
Okay, so 3/2. You put that also in brackets if you like. So at this point, okay, you solve for your N. Do we have to solve for the N, or I should give you the N value? So that
Sir,
you
please give us the N value.
Okay, so if you continue, you are going to clear the fraction. You multiply through by 2. So that will give us what? 27 is equal to 3 plus what? Before, so you get N minus 1 times 3. Okay, so if you expand and solve for your N will be equal to 9. So it means you are supposed to find S sub 9. You go, you know your A, so that will give you 9/2. So I'll write therefore S sub 9 will be equal to 9/2 into A, which is what? 3 on 2. Okay, then plus your L. And what is our L? Our L is 27, okay, on 2. Then at this point, you are in a comfortable lead. Safa. So we are asked to find the sum of the first 9 terms of the sequence that you have there, of the series that you have there. As simple as that. Okay, so with this, I believe you should be able to do this. Similar question. Is that not it?
Yes, sir.
Okay, that's okay. So please, and this is also an AP. Can you see that?
Yes, please.
Okay, so obviously we need to find this N. It's a finite. Yes, please, my prof.
Please, can you go back to the slide that has the
Yeah, I
solution
have.
to question
I have.
4?
So let me write the value there. So with this one, you end up getting your final result to be 135 on 2. But you know you have to change it to Maze numbers. Oh, this was 135 and I wrote 135 on 2. But you change it to the corresponding Maze numbers. Is that clear? Okay, so now because I know that this will give you 30 on 2, which will give you 15. So you get 15 times 9/2, which will give you 135/2. I hope I'm right. Okay, all right. So that will be it for this. So I guess I can move on. So similar to what you have here. So now let's look at this particular, okay, question. Okay, equally, I will see if I have to guide you before you can do it, or you should be able to do it on your own. Okay, I think this one I have to. This question, its nature is different from all the questions that we have done so far because this connects an AP and a GP, so together. So the first, please, I need your maximum attention at this point. Okay, we are told that the first, second, and fifth terms of a linear sequence, AP, are 3 consecutive terms of an exponential sequence. Okay, so this is all that we are going to extract, the first part of the question. So solution. Question 6. Okay, the first, and that is U sub 1, am I right? So for your AP, this will be your sequence. U sub 1 is the same as A. Do you agree? That's your first term. Your second term, and that will give you, okay, so second term is going to give us what? A, help me.
Say AR.
It will be ADO, APO. We are looking at AP. Sorry, I didn't bring the P. I hope you are with me.
Yes, please.
Okay, so the AP, that's it. I'm breaking the question. I've told you for every word problem, break it down. Okay, before. So the first term, the second. Okay, which other term do we need? Okay, we are not ordering. Okay, so our next term will be fifth term. So the fifth term is what? It will give us A plus 4D. Herbert, are you there?
Yes, sir.
Okay, so so these are the terms that you are. So now you know that for your GP. Okay, what are you going to do? We are told that these 3 terms here will be the consecutive terms of your GP. So it means for my GP, I'm going to get my first term to be A, my next term will be A plus D, and my next term will be A plus 4D. Do you agree?
Yes, please.
Please, my professors, are you with me?
Yes,
Okay,
Yes,
but
sir.
so this is it for the first part of the statement. Now let's look at the second part of the statement. If the first term of the linear sequence is 7, find the common difference. So our first term here, A is 7. So now I can say that, yes, Prof. Karen.
Mr. Agman, please, can you take the first part again?
The first part, okay. The first part, this is what we are looking at. If you read the question carefully, you've been given some particular terms of an AP. However, you are told that the particular terms of that AP, okay, they form an exponential, consecutive terms of an exponential sequence. So I was given the first term, which is U sub 1 of an AP, U sub 2 of an AP, and U sub 5 of an AP. So we obviously, if U sub 1, U sub 2, U sub 5, for your AP, they will not be consecutive terms. So that's why I didn't write that one as a sequence. Can you see that? I only wrote them in terms of the terms. They are corresponding formulas. You get it? Karen, do you get a point?
Thank
Because
you.
obviously it is the first and the second that will be consecutive, but the fifth cannot be. So I cannot write that as a sequence for the AP. So that's why I didn't use a comma. I use semicolon. So I'm not writing a sequence there because sequences, we don't use semicolons to separate your terms. Is my point well made?
Yes, please.
Okay, so now, again, you are told that these terms, they form consecutive terms of what? An exponential sequence. So they are the 3 consecutive terms. But again, I am assuming that they will be the first term. Once they are consecutive term, obviously, first term, second term, third term, that's what I'm looking at. Okay, so the first term of your GP will be A. Okay, your second term of the GP will be this particular term of your AP. The third term of what? The GP will be this particular term of what? Of your AP. So this will be my GP. Is that clear?
Yes, please.
You get it now. Okay, but
Mr. Agman,
No, please.
hey, no again.
no,
Mr.
I
Agman,
understand.
Okay, you understand. I heard another no.
yes, I don't get why AP is equal to GP when GP uses a ratio and AP uses the common
No,
difference.
we are not saying that it is equal. Okay, assuming maybe I have these two, I have the AP, I mean, I have this. I'm just assuming. I have 2, 4, 6, 8, okay, 10. This is an AP, do you agree?
Yes, please.
Okay, now I can pick some of the elements of what, or terms of your AP, and they can form a GP. So I can pick 2, 4, 8. Okay, out of the terms here. Don't I have a GP? You get my point?
Yes, please.
Okay, so some of the terms, if I pick some of the terms of an AP, if I pick them, I can use it to form another sequence, which will be a GP. That's all about the question. But I didn't pick, there is no way consecutive terms of an AP, okay, will be consecutive terms of a GP. But some of the terms there, okay, if I pick them, they can form a GP, just as you can see that I left out this. I picked this, this, and this, and they are now consecutive terms here, and these consecutive terms, they form what? A GP. You get, so that's the import of the question. So not that I'm trying to say that the first 3 terms here will also form. No, obviously they cannot. Do you get the point now?
Yes, please.
So you are told the first, the second, and the fifth term. For me, what I did here, it is the first, the second, and the third term that I used to form my GP. You get it? The first, the
please.
second, and the fourth term. But the person who said the question, or where the question is coming from, we said the first, the second, and what, the fifth terms. Okay, but you don't know the actual sequence, so you can only use formulas, the letters, to represent the terms. For this, we know the actual, okay, sequence, so we can use the actual values. Safa.
Yes, please.
All right, okay. So if you get this, okay, Prof. Inshira.
So for the GP, doesn't U1 is A, then U2 will be A plus B.
Okay.
Then U3 plus B.
Okay, very good. Remember I said, okay, they are forming, even in the previous example, I told you that we are told that they form 3 consecutive terms. It doesn't necessarily mean that will be the first 3 terms. What it means is that they are consecutive terms. It could be consecutive from the first, okay, consecutive from the second, consecutive from the third. Only that I am writing it this way just for you to know that they are consecutive terms. That's all. You get my point? Okay. Once they are consecutive terms, that's all that you need to know. Okay, Prof. Okay, Tusi. Did I pronounce the name well? Prof. Tusi, did I pronounce your name well? Your hand is up. Unmute and respond. Okay, otherwise, okay, I don't know whether it's your network. Please unmute and respond. Otherwise, I'm going to continue. Okay, so, but in the question, we are told that A is what? The first term of your linear sequence, which is A, is equal to what?
7.
7. So can I say that this implies that my GP, okay, will be equal to consecutive terms of my GP, not the actual GP, will be equal to 7 plus, oh, sorry, did I say plus? Okay, 7, comma, I'm forming my, so 7, okay, comma, then was 7 plus D, okay, comma, then 7 plus 4D. Do you agree? We are breaking the question down. Please, do you agree?
Yes, please.
Okay. Now we need to find a common difference. So we need to find a D here. You know that the D here is also the common difference because this came from that of what? Of your AP. So if this is a GP, what can you say about what we have here? Under what circumstance can you say that this is a GP and therefore I'm dealing with consecutive terms?
7 plus D over 7 will be equal to
Common ratio. As simple as that. Very good. So in this case, I can write this implies that I have only one unknown here. So I have to generate one equation. So it will be this over that, the first ratio, consecutive. Okay, then this over that must be equal. So we are going to get 7 plus D all over 7 should be equal to 7 plus 4D all over 7 plus D. So now you cross multiply, so it plus D. Okay, then you solve for your D. Afa, is my point well made, my professors?
Yes, sir.
Yes,
Okay,
please.
so we are going to solve it up to a point. We'll generate the quadratic equation, then I'll ask you to continue from there. So let's go and generate the quadratic equation together. So this will give us 7 plus D, okay, into 7, okay, plus D. Okay, and that should be equal to 7 into 7 plus 4D. Do you agree? Do you agree?
yes,
Yes,
please.
sir.
Okay, so at this point, how do you expand this? Are you going to multiply this times this times this, and this times that? Is that what you would do? Okay, you can do that, no issues. However, okay, those of us who are very smart, this is what we do. Okay, I've told you, anytime you are multiplying two binomials, check whether they are special. Same first term, same second term, same sign, they are special. Or even different sign, they are special. If same sign, okay, then it means you are looking at the same quantity squared. So I know that this will give me 7 plus D squared. So that's what I'm going to use to expand. So I know it will give me, we all know that A plus B all squared per the identity will be equal to what? A squared plus 2AB plus B squared. You know, is that not it?
Yes, sir.
So we will know that, okay, let me see. It seems I have a message. Okay, all right, Tusi. So where did you said you have a problem with my GP that I have formed. Okay, I think I've explained enough. You are told that these three terms, I mean, they are not consecutive terms anyway. These three terms, they form consecutive terms of a GP. So get your three terms of your AP and now use it to form three consecutive terms. That's all. So that gave us the GP here. And we are told that subsequently, we are told that A is equal to 7. So we substituted wherever we see A, we substituted 7. And that gave us our actual GP here, or the new version of the GP, knowing A to be this. And we said this is a GP, then you should have a common ratio. We use that to generate the equation that we are yet to simplify. So I was saying that if you can't see clearly what we are doing, then you should go through the Tuesday. I hope you are fine. Okay, great. All right, thank you. All right, so it's good you are on board. Okay, so I don't know. Please make sure you fix your audio because it's not everything that you can type for me to relate very well with. Okay, so next time work on the audio before you join class. Thanks for your understanding. So this will give us 7 squared, which is 49. Okay. Then plus twice the product of this and this. The product of this will give us 7D. Twice that will give us what? Okay, 14D. Then plus D squared. And that should be equal to expanded. This will also give us 49. Okay, plus what? What do we get here? Is it 28D? Am I right?
Yes.
Okay, you can see 49 here, another 49 here, positive, positive, so that you know they will cancel. So my point is we have a quadratic equation in D. Take everything to one side. The D here is, D squared here is positive, so it means it is better to move everything to this side, but we know that this will cancel. So I'm going to get D squared. Okay, this will come here. I'll get 14D minus 28D, and that will give me minus 14D. Okay, it's equal to 0. Do you agree? Okay, so at this point,
Yes,
you
please.
factorize. So you get your D out and you get what? D minus 14 is equal to 0. Okay, so now you are going to get D is equal to 0, or you set each of the factors. D minus 14 is equal to 0. D is equal to 0 is solved for here. So D is equal to now 14. So you draw your conclusion. Therefore, D is equal to what? 0 or 14. Is that what you write? My professor, is that what you write?
Yes, please.
Okay. All right.
help me.
Okay. So those who said no, or the person who said no, why no? And what will you write?
If since is a difference, I expect it to be a natural number.
Okay.
Or
Perfect. You are right. No or. Okay. Cancel the or. Or- Okay. So that's it. You know that obviously, assuming maybe I'm starting with 2, you just assume I have an AP. My first one is 2, and my common difference is 0. Okay, my common difference is 0. And you know that as you move on, you'll be adding your common difference. So what do you get? You'll be getting 2, 2, 2, 2. Okay, and that obviously is not a sequence that's okay. So at least your common difference should be, in terms of the positive, it should be positive 1. I mean, any fraction can also do as well, but it cannot be 0. Other than that, it will be the same numbers. Okay, and usually we don't admit common difference of 0. So this question is just trying to let you know that your 0 must be discarded. So you conclude with a 14. Is my point well made? Prof. Christine.
Yes, sir. Mr. Hackman, please. The question said we should find the common difference,
Mhm.
and we use GP to find the common difference. Could we have equally used the AP to find it?
No, because the AP, the sequences, the terms that you have there are not consecutive terms.
Yes, please.
All right, okay, so you can use this, okay, but obviously you know, okay, this and this are consecutive. So if you want to use it, then the other one you can't use it, or you get a difference here, but you need the other one to verify. So you should get at least 3 consecutive terms for any sequence before you can tell whether it is a common ratio or a common difference. Okay, very good. So if you are fine, then I guess we can move on to the next question. Okay, so this question is similar to what we just did. Okay, so the first, the fifth, the 10th terms of a linear sequence are geometric progression. So here you are told they will form the geometric progression. Don't worry, just take them as your first 3 terms. Okay, you just write them in terms of the consecutive nature. We are not interested in whether they are first 3 terms, or what is important is they are consecutive. So it means, okay, A plus, what do you call it? This is A, comma, so that will be your first term of the AP. Your fifth term will be A plus 4D. Your 10th term will be A plus 9D. So in terms of your GP will be A, comma, A plus 4D, comma, then A plus 9D, comma, then ellipsis. Is that clear?
Yes.
Yes, sir.
Okay, so then another information, you can see that you will get 2 letters involved. Okay, originally look at what we have there. Per the first statement, we had 2 letters A and D. But the second statement here give us what, a hint or one of the values. So in effect, we use only one equation. Now let's see what will come from this one, the second statement. The sum of the second and the eighth of the linear terms, that is the terms of the linear sequence, is 30. So this one too, you are told that second, which is A plus D, okay, plus the 8, because you said the sum of the second, then plus the 8. The 8 is what? A plus 7D should give you what? 30. So it means your first one, you will use the common ratio in the GP, and that will generate an equation in A and D. The second one will also give you another equation in A and D. So with this one, you have to generate 2 equations with two unknowns and you solve. Unlike the first one, that one of them was given. So this one, you will need a little more work. Is my point well made, my professors?
Yes,
Yes,
please.
Okay,
sir.
I wanted to give you a class assignment. Okay, Prof. Karen.
Mr. Hakma, how do we generate a second equation? Your line was breaking.
Hey, this one, I wasn't even supposed to say about it, so because it's once you see it in green, then you know. Okay, anyway, I can guide you. The second you are told, what is the second statement here? The first statement, we use it to generate, okay, I've said all that I'm supposed to say. The second one, we are told that the sum of the second, so the second term we know of an AP is A plus what? D. Okay, then which term? The A term is what? A plus 7D. So if the sum of these two, it will be this plus this, that should give us the 30. So now you know you are going to get 2A plus 8D is equal to 30. This equation can be reduced. So you reduce before, okay, you label. So that will give you, divide it through by 2. A plus 4D is equal to 15. So this then becomes your equation 2. The equation 1, you use the common ratio. Okay, because you have consecutive terms. So you divide the second term by the first term, which should be equal to the third term divided by the second term. You cross multiply and use that one to generate your equation. Karen Afa.
Yes, please.
Okay, very good. All right, so that will be it. So take note of this. Okay, you know where possibly you can meet it. All right. Okay, so let's look at this one too. Okay, this one too is very easy. Okay, I know that's what you are saying. I agree with you perfectly. It is very easy. All right, so let's see. Find the number of terms, okay, of the arithmetic progression this needed to make a total of what? 126. So you know, you need to find, if you are looking for the total, then it means you are looking for the sum. Is that clear? Hello, is my point well made, my professors?
Yes, sir.
Yes,
Okay, so
please.
I'm only guiding you, okay, as to, so to make a sum, so it means S sub what? N. I don't know my N because I need to find is equal to 1, 2, or 6. Okay, I'm dealing with AP, but I know that for an AP, S sub N is given by which formula? Do I know the last term?
No, please.
So I will quote the formula that is lengthy. So I know, but my S sub N, okay, for an AP will be equal to N over 2 into what? 2A plus N minus 1D. Am I right?
Yes, please.
Okay, so this implies that 126 will be equal to, I don't know N over 2 into, I know my A, so which will be 2 into 4. But then you write, but A is equal to 4, D is equal to, then you come and substitute. And you get only N in your equation, then you solve for your N. Afa,
Yes, sir.
okay, some of these questions, we did that in the call. Okay, so you should be able to relate if you watch all the videos in the call. If you have not watched, don't worry. Okay, by the time you write the test, you would have watched everything, okay, before, so that you appreciate what you have here. So your equation will be in terms of N, then you solve for N in this question. Okay, similar. The sum of the first N terms, okay, of a linear sequence is this. Adama, who mind you? We have not eaten since last week. You cannot complain.
Mr. Hakma.
Okay, so linear, we'll finish right now, don't worry. Okay, so linear sequence. So the sum of the first n terms of a linear sequence. So S sub n of your linear sequence is this. Okay, if the first term and the common ratio, so you've been given A. Oh, and how can I be common ratio? Common difference, okay. So you've been given A and what? And D. So you should be, so this one is easier compared to the first one. The first one, you were supposed to pick your A from the sequence and also calculate for your D. But this one, A and D are given directly. Okay, so if you're able to do the other one, you should be able to do this. It's the same question put in a different form. Is my point well made?
Yes, sir.
Okay, so with this one, because you don't know the sequence, but you only know the sum, okay, there is no way you'll be able to, because the sum will involve the D, the N what, and the A. So if I don't give you the A and the D, there is no way you can find the N. That's why the question has given you the A and the D. Okay, if I didn't want to give you the A and the D, then I will give you the sequence itself, just as you saw in the other one. Then out of the sequence, you will find the A and find the D. Then you go and substitute and solve whatever that you are supposed to solve for. So I guess my point is well made. We are really on track. Okay, so this will be your assignment. Okay, similar to what we just did. Okay, now let's see, we are going to solve, okay, this particular question. Okay, word problem, another application to, what do you call it, finance. Okay, so a man started a project, okay, wait, please listen and listen carefully. This is the first time you are solving questions of this nature. Okay, a man started a project with, okay, 1,160 Ghana cedis. He increases this value with 40 Ghana cedis every month until he last invested okay, so 1,760 Ghana cedis. Calculate the total amount he invested in the project at the time he invested 1,760. That is 1,760, okay, Ghana cedis. Any questions? Will you be able to do this question if I don't give you any help? Okay, so let's look at the pattern of the man's investment, okay, or savings, if you like, okay, into the project. So solution is so easy. Okay, don't let the the currency and what you have there, okay, confuse you. So 11. Okay, this is what you are giving. Okay, the first time the man invested, what is the value of investment? That is 1160. Am I right? Or just
Yes,
listen, I will give you ways that you can present your solution. I'm breaking the question down for you to appreciate. Okay, and we are told that he increases, okay, the investment by a value of 40 Ghana cedis every month. So if this is the first month investment, the second investment, okay, it will be this value plus what, 40, am I right?
yes, please.
Sure, you agree. So
Yes.
that will give us, okay, so indirectly, this is what I know I will do. And what we have there, I will know that I've been given my A to be equal to 160. And I've been given my D to be equal to 40. Do you agree?
Yes, please.
Okay. So obviously, once you have a D, you cannot talk of what a GP, but we are dealing with an AP. Is that not it? Should I come again, or my point is well made? Okay, those of you who cannot relate well, okay, let's get it from the basic meaning. So the next one, your investment, you increase it by 40. So I'm going to get one. Hey, let's go. Help me.
200.
Okay, so 200. Okay, the next one will be 1240. Am I right?
Yes.
Okay, so ellipsis. So this will be my sequence. So at this point, I'll write, this implies that A is equal to this and D is equal to that. Or I can study the nature of the sequence and write, this is an AP. For an AP, I know, then I deal with it. But what are we looking for? He said, the question asks us to calculate the total amount he invested in the project at the time he invested this. So what are you looking for?
Sum of n.
Please take note. Where are you ending? So it means this one too, you are ending at a point. Is that not it? you know the terminal point of your investment, so
Yes,
it means
please.
you know the last term. So let me bring in that for you to appreciate. Okay, because we set up to the term that this investment was made. So now you know the last term. So it's like I've given you this sequence. Okay, and you are asked to find the sum, okay, of what we have there. So this basically is the same as this. Okay, similar to what we have here. Okay, it's similar. Do you agree?
Yes, please.
It's very similar to this. Okay, only that this we are giving the sequence. Sorry, the series. Okay, it's still an AP. Okay, you were asked to find. So it's similar. I think it's very similar to one of them where you were told the number where you are supposed to make a total of 126. So take notes, but here it's in currency. So it's the same thing. So you are supposed to find S sub something, but you need to know your N before you can find. You can get your N by using your last term. So your last term, which is this, should be equal to A plus N minus 1D. You know your A, you know your D, you substitute and you find your N. And at that point, you can find your S sub N. Your S sub N will be N over 2 into A plus L. And that's what you are looking for. So at that point, you know your N. Your N value that you have there. And your N value will be, I think, 16, I guess. So it means you are finding S sub 16. Okay. And that will give you 16 over 2, okay, into your first term, which is 1160, plus your last term, which is what? 1760. Okay. Is my point well made?
Yes, please.
Oh,
Yes.
your yes is not that strong for me. Oh.
Yes, please.
Yes.
Okay, very good. All right.
Yes,
So if indeed, okay, Prof. Abba Mensah.
Sir, please, does it mean you have to do a rough work to know what term 1760 is?
Oh no, you present your solution the same way as I taught you in there. So assuming, so it means giving this. So you extract it this way, giving you get your sequence. And at this point, you know, I've told you how to, okay, get the solution for this in terms of the other one. Remember we did that. Let me see whether there was one of them that we did everything. Let me see. Oops. Okay, no, not yet. Let me see. I think it's rather in the it's similar to this. Can you see? Can you see only that the numbers, some of them were not pretty fractions, okay, and you were dealing with series, but out of series, so it means it's the same as 3 on 2, okay, comma 3 9, so that would be the sequence. Okay, the other one you had it in terms of sequence, so direct. So you determine the type of sequence, which obviously is an AP. So for an AP, you know you are finding you need a sum because it's a sum that must give you a certain invest value. So you quote, you know your last term, so you quote the formula in terms of the last. And you use this to find your N. So it will not be a rough way. You get it? As you get your N, you use your N to find, okay, the sum that we are looking for. Because the sum here depends on N, A, and L. You know A, you know L, okay, but you don't know N. So you need to find your N before you can find the actual sum. You get it?
Yes, please.
All right, okay. So I will never give you the short end of the stick, remember. Okay, so any information, I know how I arrange my question. At least you know. Okay, so this, okay, you should equally try. Okay, Mr. Ackman makes a monthly payment into his savings account. He saved 200 Ghana cedis in the first month. Okay, 800 Ghana cedis in the second month. So unlike the other one, that's the for monthly investments, you increase it by 40. So that will be your D. Okay, here let's see. The first month 200, the second month 800. The third month, okay, so let me see, as the third month 3,200. Okay, and he continued in the same proportion. So immediately proportion is mentioned. What type of sequence should come to mind?
GP.
GP. Okay, but even if this was not mentioned, you know, first month the investment is 200. second month 800, third month this. So you should know this over that will give you a common ratio. So you should equally know the type of sequence that you are dealing with. And is the last statement that you have to be very careful. In what month will his savings exceed this amount? So this where you have to be very critical. So you are looking for your SN, okay, take note, to be greater than this amount. By your SN, you know, will be in terms of N because you don't know the N. I hope you get my point because that's what the question is asking you to find. N is representing the month. Am I right?
Yes.
So you find your S ab N, which will be in terms of N because you know your A. S ab N, what will be your ratio? Will your ratio be a fraction?
No.
No, it will be a whole number 4. So it means your S ab N formula that you quote, okay, will be A, because it's a GP, into R to the power N minus 1 all over the appropriate one, R minus 1. So you know A, you know R, okay, but you don't know N. So you substitute your A and R, and that will give you your S ab N in terms of, okay, N. Then now you come and say that this is greater than what do you call it? It's really exceeds, okay, greater than 20,000. So you form that equation and solve for your N. Okay, take note, solve for your N. You've done log at a point, you end up getting maybe 4N is greater than a particular value, maybe 60,000 or so. Okay, if my memory serves me right. Okay, you can bring the power down by taking the log. You know you've done that. Your power, your N that you need, it should come down. So you take log of both sides. So it will log, okay, of 4 to the power N is equal to log of whatever that you have there, the 60,000. So at this point, N will come down. Then you get N log 4 is greater than 60, okay, log 60,000. Okay, then you write it again, divide by log 4. Log 4, you can use your calculator to get this. And I think your calculator will give you, okay, N greater than 4 point something. Okay, but because we are looking at, okay, greater than, you pick the next. Can your N be a fraction or a decimal? Hello, can your N be? No, it cannot. Okay, so you move on to the next, okay, integer. So if it was 4 point something, that will give you 5. So it is when it is in the 5th month that the amount that you have there will exceed what is there. You get there? Okay, I just want to, I think this question too, I should bring it in the test, just to try test how you can appreciate the explanation that I have given. Okay, so at this point, we are going to, okay, end the class. I think this is all about it, yes. Okay, this is all about it. So we are supposed to end here. Okay, and you try this. I wish you could do this as a class exercise. Okay, Prof. Amma.
Mr. Akman, please, could you go to the page where AP, the first, second, and fifth was the consecutive terms of GP.
Am I there?
Okay. Yes.
Okay, all right. So you capture, and so we are going to, and please take note, we are writing the elective maths test on Thursday. So make sure you prepare. On Thursday, we are writing the test. Okay. Please, the new student, those who joined maybe this week, last week. Okay, elective maths. Okay, I think we've done this about our 3rd or 4th lesson or so. So get time and watch the videos. You should be able to relate. So because I want you to revise and do whatever, I'm not going to give you any work today. Okay, so that you have ample time to revise. Is that okay?
Yes, please.
All right, so any questions before I finally bring the curtains down? Our next topic, you know, will likely be, elective math topic will likely be permutation and combination, counting principles. Okay, so if you are all fine, you don't have any questions, okay, we thank God. Okay, Prof. Amma.
Mr. Akman, Please, I want to ask a question which is not part of what we've done today, but it's under sequence and series.
That's okay.
For the recurrent decimals, so the question B
Recurrence.
says A. Recurrent sequence.
Okay. mhm.
The one that will be like right, maybe 0.16 with the point on top as infinite series.
Okay, so now I get you. You really meant recurrent decimals because we are dealing with recurrent decimals. So you were
Yes.
not wrong from the beginning. I thought maybe we are dealing with, you can see we have recurrent sequence.
Yes, please.
Okay, so here, come again. I get your point. So here, what did you do with that?
I said the one that will be like right 0.16 with the point on top of the 6
Mhm.
as infinite series.
We didn't do that. We didn't do that. We didn't do the one that your what do you call it? Your recurring decimal does not come immediately after the decimal point. I remember.
So you
I
understand what
said
I'm saying?
Yeah, I do understand. Okay, we did only the situation where the recurring digit comes immediately after the decimal point. So maybe 1.1 recurring, okay, or we even use the 0. Okay, then maybe, okay, 0.23, all the 3 recurring. But we never did 0.2, then 3, only 3 recurring.
So that's the second one. When they gave the answer, the first one was not the first answer they gave, but it was the second one.
Okay, so this is it. Quickly, let me see the time left. Okay, so this is it. Let me see if I can have a space for, okay, so I can use this space. This is it. If you have 0.1, okay, let me use 6 recurring. Okay, this is what you do. This will rather be equal to, in terms of the sequence, this will give you, please take note, this is going to give you 0.1, okay, then plus 0.06. So it will be this one going that will give you the sequence, not this.
Why is it so?
Okay, you can see that it is the recurring digit that will form your sequence. Because if I have this, do you agree that, okay, do you agree that this will be the same as 0.000, okay, 6? Okay, let me calm down. Let me start from here. So 0.1 recurring will be equal to 0.1, okay, then plus, okay, 0.06, okay, plus 0.006 plus 0.0006, okay, plus ellipsis. Do you agree?
Yes.
Okay, so the point is, cut off, okay, the one that is not recurring, cut it off. So this one will be cut off so that you get 0.006 recurring. So because what I have is the same as 0.1 plus 0.06 recurring. Do you agree? Do you agree?
No.
You don't agree? Please, okay, who agrees? I want to see whether indeed you are on your feet, you think. Okay, use your calculator to do 0.1 plus 0.06. And let me see what you will get. Use your calculator to do the whole of this. And let me see what you get. Okay, so let's do it mentally here. It's okay, we don't need a calculator. You still appreciate the point. Okay, so Amma, do you agree that it's the same as this? Are you with me?
Yes, please.
Okay, so if you add this, I'll put this. So this will give you 6 dots. Do you agree?
Yes,
If you add this, what do you get?
1.
If you add this, what do you get?
0 point.
So same, you get it.
Yes, please.
Okay, so now if you look at it, you can see that it is this that will follow the pattern. You get it? So it will be 0.1 plus the sum to infinity, of this sequence. And that sequence, your first term will be this, and your common ratio will be this over that.
Okay.
You get it now? Because
Yes,
immediately
please.
you bring in this, okay, you wouldn't see a pattern because there wouldn't be consecutive, okay, the ratio of this, and going forward, you won't get a common ratio. So it is these that will give you common ratios because you can obviously see the pattern here. This one and this, they don't have anything in common. So you come and find the sum to infinity to this one, then you add it to this. So this will give you 1 over 10. Okay, obviously you'll be working with fraction. So 1 over 10, then plus whatever that you get here. And that will give you your fraction. Because this will also be in a fraction form, remember. You get your A, your R, a substitute, which will be in terms of fraction, and you are good to go. Afa.
Yes, please.
Please, Afa. To the rest of you.
Yes.
Okay, all right. So on that note, okay, so bye-bye. God bless us all. Enjoy the rest of your day.
Bye.